Section 10 of Histology of the Blood. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by John K. Thomas, John Thomas Kuzmarski. Histology of the Blood by Paul Ehrlich and Adolf Lazarus. Translated by B. M. Myers. Section 10b. Leukemia. Mixed leukocytosis. In spite of the enormous extent of the hematological observations of the last decennia, which a very considerable portion deals with the problem of leukemia, the literature shows many obscurities and misconceptions, even on important fundamental ideas. This is especially the case with the weighty question of the distinction between various forms of leukemia. From the purely clinical standpoint, it is usual to describe a lineomedullary, and a pure medullary myelogenic form of leukemia. But the distinguishing characteristics in this classification are crude and purely external, and they find no place in hematology. Newman first showed that the lymphoid proliferation in lymphatic anemia is not confined to the lymph glands, but may extend to the spleen and bone marrow. These proliferative processes may give rise to a considerable enlargement, for example of the spleen, without any change in the specific character of the leukemia or the condition of the blood. In spite of the splenic tumor, we have to deal with a pure lymphatic leukemia. In customary clinical language, a case of this would be described as lymphatic leukemia. The unreliability and incorrectness of this terminology is best illustrated by another form of leukemic metastasis. In lymphatic leukemia, the liver may swell by lymphomatous growth to a large tumor, and we ought then to speak of a hepatolymphatic form of leukemia. This term is by no means so misleading as lymphatic, for no one would conclude from the former that any liver cells passed into the blood, whilst the latter implies the idea that specific splenic cells take part in the blood changes. Further, the assumption of a pure lineal variety of leukemia is totally unwarranted from hematological investigations. The possibility of a specific blood change, depending solely upon disease of the spleen, appears a priori almost excluded after what has been said on the physiological participation of the spleen in the formation of the blood. Pathological data completely confirm this view. Ehrlich, at least, in an enormous number of cases, has never once succeeded in confirming the existence of a purely splenic form from the blood examination. The conditions in myelogenic leukemia are quite similar, for foci of myeloid tissue may appear in the spleen or lymph glands according to the kind of metastasis. As it is the proliferation of the myeloid tissue and not the accompanying swelling of spleen or lymph glands that is specific in the process, the nomenclature lienomedullary or medullary lymphatic leukemia must also be described as illogical and misleading. We distinguish then from the histological standpoint but two forms of leukemia: leukemia processes with proliferation of lymphoid tissue, lymphatic leukemia; 2. Leukemic processes with proliferation of myeloid tissue, myelogenic leukemia. The accompanying clinical phenomena may be indicated by simple, unequivocal amplifications. For instance, lymphatic leukemia with enlargement of the spleen or of the liver, myelogenic leukemia with enlargement of the lymph glands. From our present knowledge, which it may be remarked is still far from full, we may assume that lymphatic and myelogenous leukemia have quite a different etiology. The recent discovery of Löwit should be decisive on this point, for he demonstrated in myelogenic leukemia the presence of forms like plasmadia within the white blood corpuscles, but was unable to find them in lymphatic leukemia. The necessity of separating lymphatic from myelogenic leukemia is further shown by the fundamental clinical differences between them. Lymphatic leukemia falls clinically into two readily distinguishable forms. In the first place, acute lymphatic leukemia, characterized by its rapid course, the small splenic tumor, the tendency to petechiae, and to the general hemorrhagic diathesis. By its startling course, this disease has given all observers the impression of an acute infectious process. The second form of lymphatic leukemia is marked off from the preceding by its chronic and often very protracted course. The spleen shows its participation in the disease as a rule by a very considerable enlargement. We have at present no investigations adequate to decide whether chronic lymphatic leukemia represents a single disease or should be etiologically subdivided. Hematologically, all lymphatic leukemias are characterized by a preponderance of lymph cells,
in particular of the larger varieties.
It should here be expressly mentioned that richness of the blood in large lymph cells is by no means characteristic of the acute form of leukemia, for chronic, very slowly progressing cases show the same condition. Thus, in a case of this kind under observation in Gerhardt's wards, all observers, Grawitz, Noorden, Ehrlich, found the large cells during its whole course. In agreement with our remarks elsewhere, see page 104, we assume with regard to the origin of lymphatic leukemia that the increase of the lymph cells is brought about by a passive inflow into the blood and not by an active emigration from chemical stimuli. Myelogenic leukemia presents a picture that is different in every particular. In former years, the distinction between myelogenic leukemia and simple leukocytosis offered great difficulties. These conditions were regarded as different stages of one and the same pathological process, and when the proportion of white to red corpuscles exceeded a certain limit, 150, it was said that leukocytosis ceased and leukemia began. By the aid of the analytic color methods, the fundamental difference between the two conditions was first disclosed. Leukocytosis is now recognized to be chiefly an increase of the normal polynuclear neutrophil leukocytes, whereas myelogenic leukemia brings elements into the blood that are abnormal. The cells here introduced are so characteristic as to render the diagnosis of leukemia possible, even in the rare cases where the total number of the white blood corpuscles is not to any extent increased. The best example of which we are aware is a case observed by V. Noorden, in which the proportion of white to red was only 1 to 200. Although the blood picture of myelogenic leukemia has been so clearly drawn by Ehrlich, misconceptions and obscurities still occur in the literature. And they are due to great errors in observation. It has, for instance, happened that unskilled observers have regarded and worked up cases of lymphatic leukemia as myelogenic. The apparent deviations discovered in this manner are copied, as specially remarkable, from one book to another. Through insufficient mastery of the staining method, the characteristic and diagnostically decisive elements, neutrophil, myelocytes, for example, are frequently mistaken. A further source productive of misconceptions lies in the circumstances that the typical leukemic condition of the blood may essentially change under the influences of intercurrent diseases. Thus, the intrusion of leukocytosis brought about by secondary infection is able to obliterate more or less the specific character of the blood. Such conditions must naturally be considered apart and should not be used to overthrow the general characteristics of the picture. No one surely would deny the diagnostic value of glycosuria for diabetes, because in conditions of inanition, for instance, the sugar of a diabetic may completely vanish, although disease continues. And one does not deny the diagnostic value of the splenic tumor in typhoid fever, because of the enlargement of the spleen may occasionally subside under the influence of an intestinal hemorrhage. From these considerations, it is obviously necessary to derive the description of leukemic blood from pure, uncomplicated cases, and to construct it with the aid of standard methods. In this manner, a type is obtained so characteristic as to render diagnosis absolutely certain from the blood alone. It is needful here to emphasize this hundredfold repeated experience with special distinctness, for some recent authors do not even yet allow the full diagnostic importance of the blood examination. V. Limbeck says in the latest edition of his Clinical Pathology of the Blood that one should not regard the blood changes as an invariably reliable diagnostic resource in myelogenous leukemia, and that the diagnosis of leukemia should not rest on the presence or significance of one or more cells. Not only the general features of the case, but the blood condition as well, should be considered. To these remarks, the objections must be made that up to the present no serious hematologist will have had to diagnose a leukemic disease principally from the presence of one or more cells. In the work of Ehrlich, and his pupils at least, it has always been shown that the character of a leukemic condition is only settled by a concurrence of a large number of single symptoms, of which each one is indispensable for the diagnosis, and which taken together are absolutely conclusive. With these premises, it is indisputable that the microscopic examination of the blood alone, on dry preparations, without the assistance of any other clinical method, can decide whether a patient suffers from leukemia and whether it belongs to the lymphatic or myelogenic variety. The microscopic picture of myelogenic leukemia, disregarding the almost constant increase of the white blood corpuscles, has a varied, highly inconstant character. This arises from the cooperation of several anomalies, namely a. that in addition to the polynuclear cells, their early stages, the mononuclear granulated corpuscles, likewise circulate in the blood.
B. That all three types of granulated cells, the neutrophil, eosinophil, and mast cells, participate in the increase of the white blood corpuscles. C. That atypical cell forms appear, example dwarf forms, of all the kinds of white corpuscles, and further mitotic nuclear figures. D. That the blood always contains nucleated red blood corpuscles, often in great numbers. 1. We begin with a discussion of the mononuclear neutrophil cells, Ehrlich's myelocytes. They are present so abundantly in the blood of medullary leukemia as to impart to the whole picture a predominantly mononuclear character. As we have frequently mentioned, myelocytes occur normally only in the bone marrow, not in the circulating blood. Their eminent importance for the diagnosis of myelogenic leukemia, where there have been regularly found by the best observers, is in no way diminished by their transitory appearance in a few other conditions. See pages 77-78. Though they have been occasionally found, according to Turk's investigations, in the critical period of pneumonia as parts of a general leukocytosis, the danger of confusion with leukemic blood changes is non-existent. This is guarded against by 1. The much smaller increase of the white cells, 2. The diminution of the eosinophil and mast cells, 3. The fact that the myelocytes of leukemic blood are nearly always considerably larger, 4. The preponderating polynuclear character of the leukocytosis, which is not effaced by the small percentage amount of myelocytes, at most 12%. 5. The incomparably smaller absolute number of myelocytes. In the most pronounced case of Turks, for example, in which the percentage number of myelocytes amounted to 11.9, calculation of their absolute number gives at most 1,000 myelocytes per millimeter cubed. This is a figure which bears no comparison with that obtaining in leukemia, where 50,000 to 100,000 myelocytes per cubic millimeter and over occur in cases that are in no way extreme. 2. The mononuclear eosinophil cells. Before the introduction of the staining method, Mosler had described large, coarsely granulated cells, marrow cells, as characteristic for myelogenic leukemia. These are to be regarded as for the most part identical with the mononuclear eosinophil cells, noticed by Müller and Raeder as peculiar and aptly described by them as eosinophil analogues of the preceding group. They appear as large elements with oval, feebly staining nucleus. Undeniably a valuable sign of leukemia, they are not nearly so important as the mononuclear neutrophil cells, as follows from the numerical superiority of the latter. To regard the presence of eosinophil myelocytes as absolute proof of the existence of a leukemia is inadmissible, since they are occasionally present in small numbers in other diseases. The absolute increase of the eosinophil cells. In his first paper on leukemia, Ehrlich stated that the absolute number of polynuclear eosinophils is always much increased in myelogenic leukemia. This assertion of Ehrlich has been received under some protest. V. Limbeck, in his textbook, even speaks of an alleged increase of the eosinophil cells. The well-known work of Müller and Raeder has more particularly given rise to this opposition and thrown doubt on the diagnostic importance of the eosinophil cells. These authors, however, base their contradiction on false premises, for Ehrlich did not speak of a rise of the percentage of the eosinophil cells, but only of an increase in their absolute number. In a case of leukemia, only the normal percentage number of eosinophils is found. It indicates, all the same, a great absolute increase, and Müller and Raeder would themselves have fully confirmed Ehrlich's statement, had they only calculated the absolute figures in a few of their cases. Selecting from the 7 cases in this paper, those where it is possible from the given data to obtain the absolute number of the eosinophil cells, we get the following results. Case 29, 3.5% EOS, 14,000 per millimeter cubed. 30, 3.9%, 8,000. 31, 3.4%, 11,000. The figure given by Zappert as a high normal value is 250. In these cases, there is an average number of 11,000. That is 50 times as great. The observations then of Müller and Raeder themselves suffice fully to confirm Ehrlich's statement. The absolute number of eosinophil cells depends naturally to a certain extent on the relative proportion of white to red corpuscles, and the greater the relative number of leukocytes, the greater should be the number of eosinophils. Zappert, for instance, found the following figures in his cases. Proportion of white to red corpuscles, absolute number of eosinophils, 1 to 24, 3,000 to 4,560, 1 to 18, 3,300, 1 to 15, 7,000, 1 to 13, 8,700, 1 to 11, 6,000, 1 to 7.6, 8,300, 1 to 7.0, 7,600, 1 to 7.0, 29,000, 1 to 5.0, 14,000, 1 to 3.8, 34,000. Apart from the approximate parallelism between the two rows of figures, this abstract shows that the minimal value, 3,000 eosinophils, with a proportion of white to red of 1 to 24, still amounts to 15 times the normal. The maximal figure found by Zappert of 30,000 is moreover by no means to be considered extreme. Cases of leukemia are not infrequent in which we find 100,000 eosinophils per millimeter cubed and over.
From these figures, it must be admitted that the absolute increase of the eosinophil cells in medullary leukemia is not alleged, v. Limbeck, but, on the contrary, is very real and considerable. That the absolute and relative number of eosinophil cells may markedly sink in certain complications of leukemia constitutes no exception to the law that the eosinophil cells are increased in myelogenic leukemia. In this connection, the self-evident principle must be observed that only analogous conditions are comparable. The standard of comparison for a leukemic patient suffering from severe sepsis is not the blood of a healthy person with normal numerical proportions, but that of a patient similarly attacked by a severe sepsis. Now we know that in sepsis the number of eosinophil cells is enormously diminished, so that Zappert, in 5 cases of this nature, was unable to recognize any eosinophils in the blood. In contrast to this stands a case of myelogenic leukemia, described by Ryder and Mueller, complicated by a severe and lethally ending suppurative process. In consequence of the acute neutrophil leukocytosis brought about by the septic infection, and the number of eosinophils sank rapidly from 3.5% to 0.43%. 4 hours before death. The absolute number of eosinophil cells, however, in this terminal stage still amounted to 1,400 to 1,500 per millimeter cubed, and was therefore, in comparison with an uncomplicated sepsis, very much raised. Writers should not have disputed the importance of the eosinophil cells for the diagnosis of leukemia from cases like these. On the contrary, they should have seen in them a decisive confirmation of the constancy of the absolute increase of the eosinophils in leukemic blood. At the time when Ehrlich formulated his proposition on the diagnostic importance of the eosinophil cells in leukemia, the simple eosinophil leukocytosis, see page 148, first discovered later by the investigation of asthma, etc., was unknown. For no confusion can arise between leukemia and conditions accompanied by eosinophilia, as they can be distinguished on clinical grounds alone. The blood, moreover, provides ample means for a differential diagnosis. 1. The total increase of the white cells in this case seldom reaches degrees that remind one of leukemia. 2. The eosinophil cells are exclusively polynuclear. 3. Mast cells and neutrophil myelocytes are almost entirely absent. In favor of the diagnostic value of the absolute increase of the eosinophil cells are those cases too, where with a blood condition closely recalling leukemia, the absence of eosinophil cells excludes the diagnosis of that disease. In a case of carcinoma of the bone marrow, described by Epstein, with an anemic constitution of the blood nearly always present, it may be mentioned in leukemia. There was found a marked increase of the white blood corpuscles, numerous neutrophil myelocytes, and nucleated red corpuscles. Anyone holding, as Mueller and Ryder do, that the number of eosinophil cells need not be considered in the diagnosis, must in this case have diagnosed myelogenic leukemia. This, however, was, according to Ehrlich's system, impossible owing to the complete absence of eosinophil cells. From all these observations it follows that an absolute increase of eosinophil cells is indispensable for the diagnosis of leukemia. 4. The absolute increase of the mast cells. The mast cells are always increased in myelogenic leukemia. They may be counted in leukemic blood
with the aid
of the triacid or eosine methylene blue stain. As shown by the former, they appear as polynuclear cells free from granules, since their granulation takes on no dye of the triacid mixture. In all cases of myelogenic leukemia, the increase of mast cells is absolute and considerable. Generally, they are equally or half as numerous as the eosinophils. Occasionally, they may exceed the latter in number. Hence, it follows that the mast cells undergo an increase in number relatively greater than the eosinophil cells, for they normally amount only to some 0.28%. They are perhaps of greater diagnostic value than the eosinophils, because up to the present time we know of no other condition, in contradistinction to eosinophil leukocytosis, in which a marked increase of the mast cells occurs. 5. Atypical forms of the white corpuscles. Amongst these are to be mentioned a. Dwarf forms of the polynuclear neutrophils and of the eosinophil elements respectively. As a rule, they resemble normal polynuclear cells on a small scale. b. Dwarf forms of the mononuclear neutrophil and eosinophil leukocytes, which correspond to the pseudo-lymphocytes described elsewhere, see page 178. The importance of these dwarf forms for leukemia is as yet insufficiently explained, and it is difficult to decide whether they are already small forms on reaching the bloodstream, or whether they are there produced by division of a large cell. C. Cells with mitoses. Formerly particular weight was laid on the observation of mitoses, for they were regarded as evidence that the increase of white blood corpuscles was brought about in the circulating blood itself, an assumption specially supported by Löwit. A large number of authors, H. F. Müller, Wertheim, Ryder, have demonstrated mitoses, particularly of the myelocytes, in the circulating blood in leukemia. No diagnostic importance of any kind can, however, be ascribed to them. They are found in all cases only in very small numbers. Thus, Müller says that he generally must look through many thousand of white cells before meeting one mitosis. Only in one case did he find the figures of nuclear division somewhat more abundant, where there was one mitosis only to several hundreds of leukocytes. These really negative observations show that the mitoses play a complete negligible part in the increase of the cells in the blood itself. For the diagnosis of leukemia, they are valueless. 6. Nucleated red corpuscles form a constant constituent of leukemic blood. In different cases their number is very varying. In one case they occur extremely sparingly, in another every field contains very many. The normoblastic type is found most frequently, but side by side with it, megaloblasts and forms transitional between the two are occasionally found. Mitoses within the red blood discs have been described by different authors, but possess no theoretic or clinical importance. The appearance of erythroblasts in leukemia may be either a specific phenomenon or merely the expression of an anemia accompanying the leukemia. We are inclined to the first supposition, since the occurrence in such numbers of nucleated red cells is hardly ever observed in other anemias of the same severity. So much for the characteristics of leukemic blood, upon which the diagnosis of the disease is made. We must add that although in any case of medullary leukemia each particular factor described is to be recognized, yet the same manner of its appearance, its numerical relation to the others and to the total blood varies extremely. Apart from the degree of increase of the leukocytes, no one case is the same as another with regard to the other anomalies. In one case, the blood bears a large-celled mononuclear neutrophil character. In another, the increase of the eosinophil cells predominates. In a third, the nucleated red blood corpuscle preponderate. In a fourth, we see a flooding of the blood with mast cells, and hence results a multiplicity of combinations, and each single case has its own individual features. It is of special importance to study the changes due to certain intercurrent diseases in the blood picture of medullary leukemia. This point has recently been the object of detailed investigation, in particular by A. Frankel, Leitheim, and others. According to these authors, under the influence of febrile diseases, the total number of leukocytes may be enormously decreased. The blood, moreover, is altered so that the myelemic characteristics become less marked, and the polynuclear neutrophil elements largely preponderant. The latter may attain the percentage numbers of common leukocytosis up to 90% and over. We will here mention a few rare cases, demanding special attention, showing the alterations leukemic blood may undergo, and occasionally presenting almost insuperable difficulties in diagnosis. We find but a single case of this kind mentioned in the literature. Zappert reported a patient who in February 1892 had shown the typical signs of myelogenous leukemia. Amongst others, the relation of white to red cells was found to be 1 to 4.29, and 1400 eosinophil cells per millimeter cubed. 3.4% were counted. At the end of September of the same year, the patient was brought in a miserable condition to the hospital, where she soon died with gradually failing strength. During this period of observation, the proportion of white to red was 1 to 1.5. The percentage of eosinophils 0.43. The mononuclears, most of which had no neutrophil granulation, amounted to 70% of the leukocytes. Zappert expressly mentions that these mononuclear cells were in no way similar to the lymphocytes in general appearance. At the autopsy, Zappert found the bone marrow studded with non-granulated mononuclear cells, and the eosinophil cells were much more scanty than is usually the case in leukemic bone marrow. Blaschstein, under Ehrlich's direction, investigated a second case of this kind. This patient had also been the subject of exact clinical investigations for some time on account of myelogenous leukemia. During the time he was last in hospital, the blood could only be examined a day before the fatal termination, the direct consequence of a septic complication. With a markedly leukemic constitution of the blood, there were found 62% polynuclear cells, 17.5% mononuclear cells, about the size of the ordinary myelocyte, 0.75% eosinophil cells, nucleated red blood corpuscles in moderate amount, the preponderance of polynuclear, and the small number of eosinophil cells is readily explainable from the septic infection. On the other hand, the absence of granules in the mononuclear cells is most surprising. These two observations can only be interpreted by assuming a loss, in certain terminal stages, on the part of the organism, of its power of forming neutrophil substances. Similar conditions occur in non-leukemic conditions. For example, in a striking case of post-hemorrhagic anemia described by Ehrlich. It is of great importance to direct attention to these cases, which up to the present have been practically disregarded, for ignorance of their occurrence may easily give rise to gross errors concerning the nature and origin of the mononuclear cells and to the manufacture of a lineal form of leukemia. Finally, we have to discuss the important question how the origin of myelemic blood is to be explained. According to our conceptions, two possibilities come under consideration. Either we have to deal with a passive inflow of bone marrow elements, or with an active emigration from the bone marrow into the circulation. This important and difficult question is certainly not fully ripe for discussion. The most weighty objection to be raised against an active emigration of the bone marrow cells is derived from the behavior of the white blood corpuscles on the warm microscopic stage. These investigations have been performed by a number of authors, of whom may be mentioned Biasidecki, Newman, Hayem, Lowett, Mayett, Gilbert, and particularly H. F. Mueller. On the ground of his summary of this subject. Concerning the behavior of the forms of cells here involved, all authors are agreed that under no conditions do the lymphocytes show the smallest spontaneous movement, whilst the polynuclear neutrophil cells always exhibit vigorous contractility. With regard to the forms most characteristic of leukemic blood, the statements are partially contradictory. Some authors deny all spontaneous movement of these cells, but most of them report observations from which it follows that a certain power of spontaneous movement is not to be gainsaid. It will be admitted that in questions of this kind, negative results are weakened by positive data. Thus Jolly recently described similar observations as follows. S'étient des changements de forme sur place longs et peu considérables, formation des poussières à grands rayons, passage d'une forme arrondie à une forme ovulaire au bilobie, etc. Ces mouvements étant visibles dans les observations et appartenant surtout à des globules de grande taille, it is naturally impossible to decide if these minute movements suffice for a spontaneous locomotion, but one cannot exclude offhand the supposition that they do. It is indeed supported by a further observation of Jolly on the mononuclear eosinophil cells of the marrow. Hitherto, it was taken for established that these cells are completely devoid of spontaneous movement. Jolly, however, was recently able to examine a specimen from a case of typical leukemia, in which nearly all the eosinophil cells showed active movement. He says, ces globules granulo-actifs présentent des mouvements de progression et de changement de forme caractéristiques et rapides. Cependant, je n'ai pas vu ces globules présenter des pseudopodes éphiles. De plus, leurs contours restent presque toujours assez nettement arrêtés. Ces particularités correspondent exactement à la description qu'en donne depuis longtemps Max Schultz des mouvements des cellules granules de sang normal. Examination of dry specimens from the same case showed, as Jolly expressly mentioned, that the blood contained, as leukemic blood always does, polynuclear and mononuclear eosinophil cells. In contrast, then, with all earlier observations, Jolly has demonstrated an active spontaneous movement of the mononuclear eosinophil cells. The amoeboid movement of the mononuclear cells is so seldom seen, not because they lack this function, but obviously from defects in the methods of investigation, which, as is manifest, are rather rough and wholly unsuited for delicate biological processes. There are many instances in the literature of the failures of this method, even in the case of cells with undisputed mobility. Thus, Ryder failed to observe any contractility in the majority of polynuclear leukocytes in a case of malignant lymphoma, whereas, according to other observations, they possess this property without exception. We think then we must draw the conclusion that the feeble mobility of the mononuclear cells, both eosinophilous and polynuclear, is only apparent, and is owing to the gross method of investigation. In reality, they doubtless have mobility sufficient for emigration. A further, but much less weighty objection to the view that myelogenic leukemia is an active leukocytosis is that pus artificially produced in leukemic patients has nearly always the histological constitution of normal pus. But from our previous detailed remarks, we should only expect a myelemic constitution of the pus if the specific morbid agent of leukemia were present in a concentrated form at the place of inflammation, just as we saw in pemphigus. Neusser's eosinophilous suppuration occurred only in the specific pemphigus bullae, but not in the foci of suppuration that were artificially produced. We know that the myelocytes are in no way positively influenced by the chemiotactic stimuli of ordinary infectious agents. On the contrary, it clearly follows that the above-mentioned observations on the transformation of leukemic blood under the influence of infectious diseases, that the common bacterial poisons act in a negatively chemiotactic sense, both on the eosinophil and on the neutrophil mononuclear cells. Under these circumstances, we should indeed expect that artificially produced suppuration in leukemic patients would have not a myelemic but a polynuclear neutrophil character. It will be the task of further investigations to examine accurately inflammatory products, example, pleuritic exudations in leukemic patients, with the object of elucidating the question whether under special conditions of disease all the leukocytes characteristic for leukemia may not be able to wander from the blood. Thus, in the case of pleurisy in a leukemic patient, Ehrlich received the impression from the preparations that a myeloid emigration had in fact occurred, carrying all of the elements in the blood into exudation. This observation does not prove the point, for numerical estimation of the proportion of white to red blood corpuscles in the exudation was not made, and these estimations are necessary in order to prove indisputably the active emigration of the white blood corpuscles into the exudation, and to exclude their purely mechanical passage per rexin from the bloodstream. The hypothesis of the active origin of myelemia is considerably supported by a further train of argument. In leukemia, besides the myelocytes, the polynuclear leukocytes are also enormously increased, and their active emigration is beyond doubt. And the view that the mononuclear cells are washed into the blood excludes that of a single mode of origin of the leukemic blood condition, and commits us to a highly artificial explanation of its production. The morphological changes of leukemic blood under the influence of infectious diseases can only be explained from the standpoint of the emigration theory. For if the white blood corpuscles were mechanically carried out of the bone marrow as a whole, it is incomprehensible that a bacterial infection should alter this process to a polynuclear leukocytosis. This change of character is easily explained, on the other hand, as we have above shown more in detail, by the assumption that ordinary bacterial poisons act positively chemiotactically only on the polynuclear neutrophil cells, but negatively on the other forms. We explain the origin of leukemic blood by the emigration into the blood under the influence of the specific leukemic agent, not only of the formed polynuclear elements, but also of their mononuclear, eosinophil, and neutrophil early stages, and to classify myelogenic leukemia with the active leukocytoses. End of section 10. Leukemia. Recording by John Thomas Kuczmarski. www.validateyourlife.com.
Section 11 of Histology of the Blood by Paul Ehrlich. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Morgan Scorpion. Histology of the Blood by Paul Ehrlich and Adolf Lazarus. Translated by M. Myers. Section 5. Leukopenia. Diminution of the white blood corpuscles. Leukopenia. Diminution of the white blood corpuscles plays, comparatively with their increase, a very unimportant role in clinical observations. It occurs in but few groups of diseases, and but seldom attains a marked degree. Koblanck has described a most marked fall in the number of colourless cells in the following remarkable blood condition. In a strong man, 25 years of age, whose internal organs were found to be healthy, short epileptiform attacks occurred, in one of which death took place. The autopsy gave no indication of the cause of death. 2 examinations of the blood were made in the course of the 3 days he was under observation. In one of these, out of 10 cover-glass preparations, not a single white blood corpuscle was found, and in the second only 1 example. We have mentioned this case here, because it is remarkable as an extreme leukopenia never before observed. An explanation, however, is impossible owing to the obscurity of the general clinical condition. For the rest of the conditions, under which a considerable diminution of the leukocytes occurs, are very well known. We distinguish 2 chief groups. 1. Leukopenia from destruction of a portion of the white blood corpuscles. Löwit. 2. Leukopenia from deficient inflow of white corpuscles. Alpha. In infectious diseases from negative chemiotaxis. Beta. In anemia, etc., from defective action of the bone marrow. We have entered more fully into the leukopenia experimentally produced by Löwit in the chapter on leukocytosis. We there explained that according to present views we have to deal, not with an actual destruction of the white elements, but merely with an altered distribution within the bloodstream. Amongst the infectious diseases where hypoleukocytosis occurs, typhoid fever must first be mentioned. The diminution is chiefly at the expense of the polynuclear cells. Uncomplicated measles, too, generally runs its course with a marked leukopenia, especially distinct during the breaking out and at the height of the exanthem. These cases of infectious leukopenia are to be explained, not by a destruction of white corpuscles, but rather by a diminished inflow, brought about by the circulation of substances negatively chemiotactic for the polynuclear elements. Leukopenia has still another meaning in certain cases of severe anemia, where it indicates a highly unfavourable prognosis. Ehrlich has described, Charité Annalen 1888, a case of post-hemorrhagic anemia ending fatally, where an extreme diminution of the leukocytes occurred. Exact figures showed that the greater proportion, 80%, of white blood corpuscles consisted of lymphocytes, whilst the polynuclears amounted to 14%, instead of 70 to 72% normally. Eosinophil cells and nucleated red blood corpuscles were entirely absent. Ehrlich explained these phenomena by a deficient activity of the bone marrow, which found expression in the insufficient formation of red and white blood corpuscles. As the anatomical basis of this deficient activity, he conjectured that in this case the fatty marrow of the big long bones could not have been changed to blood-forming red marrow, as is the rule in severe anemias. In 2 cases the autopsy fully confirmed this diagnosis made during life. The blood platelets, the hemoconiae. The blood platelets were first described by Hayem, later by Bizzozero, as a third formed element of normal blood. They are roundish or oval discs free from hemoglobin. They are extremely unstable under mechanical, thermal, and chemical influences. Their size amounts to some 3 microns. Specifically characteristic is their tendency, the result of their extraordinary stickiness, to run together into largish clumps, grape clusters. This circumstance greatly facilitates the distinction of the blood platelets from the other formed elements, but renders their enumeration most difficult. The apparatus usually used for counting the blood corpuscles is, for this reason, deceptive, for the platelets rapidly cling to its walls and remain there. All early authors, e.g. Bizzozero, endeavoured to obviate this error by some particular diluting fluid, but a number of these elements still remained fastened to the walls of the capillary tube of the mixing apparatus. Recently, Brodie and Russell have recommended a new mixture in which the platelets remain quite isolated, and are stained at the same time. They allow the drop of blood as it comes from the puncture to enter a drop of the fluid, and then estimate the relative proportion of red blood corpuscles to platelets. Footnote 36. The physiological figures found by Brodie and Russell with the aid of this method exceeded considerably those of earlier authors. They found a proportion of platelets to erythrocytes 1 to 85, or an absolute number of about 635,000 per millimetre. End of footnote 36. The prescription for their solution is as follows: Dahlia glycerin, 2% solution of common salt, equal parts. Another method, used by the majority of more recent authors, is the relative enumeration of blood platelets in the stained dry specimen. Ehrlich found that the blood platelets were picked out by their deep red colour, corresponding to the amount of alkali they contain, in preparations treated by the iodine eosin method, see page 46. Rabel's new method is much more complicated, and in no way more serviceable, depending on a stain with iron hematoxylin recommended by E. Heidenhain for demonstration of the centrosomes. A process of Rosins, not yet published, is more convenient. It consists in fixing the dry preparation for 20 minutes in osmic acid vapour, and staining in a concentrated watery solution of methylene blue. With regard to the significance of the blood platelets, most authors, of whom we should before all mention Hayem, Bizzozero, Laker, assume justifiably that they are preformed in the living blood. The view opposed to this, advocated more particularly by Löwit, that these forms first arise in the blood after it has left the vessels, we may describe on the grounds of our own extensive observations as inaccurate. The blood platelets, on the grounds of their small size and complete lack of nuclear substance, are generally regarded as not analogous to real cells. Whether they represent intravital precipitation of substances of the plasma, or whether they are budded off from the cells, cannot at the present be decided with certainty, though many facts seem to support the latter assumption. That they contain glycogen, see page 45, marks them as descendants of the blood cells. Moreover, appearances are often met with in dry preparations that arouse the suspicion that the platelets arise from the red blood corpuscles, Körper. Arnold has further observed processes of budding in the red blood corpuscles, and not only extravascularly, but also intravascularly in the mesentery of young guinea pigs, and has seen the elements that were cut off change into forms free from hemoglobin. Our knowledge, too, of the physiological function of the blood platelets still needs much amplification. The original view of Hayem, who regards the blood platelets as early stages of the red blood discs, and for this reason calls them hematoblasts, is, according to the judgment of most hematologists, untenable. Nearly all more recent papers, on the other hand, C.P. Löwit's compilation, recognise the close connection of the blood platelets with coagulation, first observed by Bizzozero. Whether the substance of the platelets directly yields the material for fibrin formation, as Bizzozero holds, or whether, according to the observations on thrombus production of Eberth and Schimmelbusch, they play but a subordinate part, is not yet decided. To enter here into the chemical side of this complicated problem would lead us much too far, and we will only refer to a few clinical observations which illustrate the relations between the clotting power of the blood and the number of platelets it contains. Marked increase of the blood platelets occurs in chlorosis, Muir, and in post-hemorrhagic anemia, Hayem. In both conditions there is a decided increase in the clotting power of the blood. In contrast is the important observation of Dennis, who found in 2 cases of purpura, where as is well known the clotting power of the blood is always much lowered or may even be entirely destroyed, only 1 morphological blood change, a very marked diminution of the blood platelets. Ehrlich likewise had occasion to examine a similar case, in which the blood platelets were entirely absent. H. F. Miller has described a 4th form constituent of the blood, and given it the name of hemoconiae, or blood atoms, blood dust. It is found in the plasma of the blood as very small granule or cocci-like colourless corpuscles, highly refractile, with a very active molecular movement, which keep their shape under observation for a very long time without any special precautions. According to Müller, these bodies are not blackened by osmic acid, and probably contain no fat. They seem to have no connection with fibrin formation, as they always lie outside the fibrin network. Müller found them in every normal blood, in varying numbers however, much increased in the case of a morbus Addisonii, diminished in hunger and cachexias. More detailed observations are necessary to determine the chemical nature of these forms. Experiments in this direction by extracting with ether, or by the use of fat-staining substances, alkanna, Sudan dye, and comparative investigations on leukemic blood should be successful. End of Section 11. End of Histology of the Blood by Paul Ehrlich and Adolf Lazarus. Translated by M. Myers.